Hello everyone, it's a pleasure meeting you all in my mathematics class again. Today, let me introduce another distribution called the Weibull distribution. And this Weibull distribution is applied for finding the life and the reliability of the components of parts in a machinery. And we say that a random variable x, follows Weibull distribution if the probability density function is given by x follows Weibull distribution if PDF of x is given by fx of x is equal to alpha by beta into x by beta to the power of alpha minus 1 into e to the power of, it is minus x by beta to the power of alpha with x greater than 0 and alpha comma beta or greater than 0. This is the probability density function of a Weibull distribution. This is a continuous random variable and the range of it is from 0 to infinity, and these two are parameters. Alpha is called the shape parameter, and beta is called the scale parameter. And you see that if alpha is less than 1, the probability of the life of the components will be more. And if alpha is equal to 1, the probability of the life follows a random variable. And if alpha is greater than 1, then the probability of the components will be affected because of the aging and also the wear and tear of the components. And here this is a scale parameter which we talk about the length of life of the components. So these are the something which are important to be known about the parameters alpha and beta. Now, as we have done in other distributions, I have taught some 4 or 5 distributions. As we have done in the distributions like discrete distribution or continuous distribution, because discrete distributions we have seen binomial distribution, Poisson distribution and geometric distribution like that, and they are all discrete distributions for which we have found the mean and variance. Likewise, I have found the expectation and the mean, expectation and the variance of the exponential distribution also. This is a continuous distribution for which also now I will tell you how the mean or expectation of and the variance of the Weibull distribution should be found. I will derive that. Now, I will write something here. We know that the nth moment of a random variable x here it is a continuous random variable. I will write here continuous. This is a continuous random variable. Continuous random variable is given by e of x to the power of r is equal to, it is here 0 to infinity, here I am taking it as 0 to infinity. It is x to the power of r into f of x into d of x. F of x is the PDF of the distribution. So this is the definition of the orth moment of a random variable that follows a continuous distribution. Now you see that if r is equal to 1, we get our mean. If r is equal to, that is the first moment. If r is equal to 1, we get the first moment. If r is equal to 2, e to the power of x squared, which is the second moment. So you see that when r is equal to 1, e of x, which is equal to mean, which is the mean of x, and e of x squared, second moment, and sigma of x squared is equal to e of x squared minus e of x whole squared. So these two are the two important things. For a third moment, fourth moment, they give what is called they talk about the QNS and the kurtosis. We can talk about using that. But here we are very much concerned about finding the mean and also the variance of the random variable x that follows the Weibull distribution. Now, I'll start with this. See, we know that, I'll rewrite this, we know that E of x to the power of r, orth moment, is equal to, it is 0 to infinity, x to the power of r, alpha by beta, into x by beta to the power of x by beta to the power of alpha minus 1 into e to the power of minus x by beta whole to the power of alpha into dx. So this is the orth moment. Now we have to integrate this. See, let me suppose, let we will do first the integration and then apply the limit. See, let e to the power, see, x by beta to the power of alpha be equal to your, let us suppose that a new variable, change of the variable which I will take. So this implies, therefore, differentiate both sides with respect to x. So what is that you get? It is alpha into x by beta into alpha minus 1 into differentiate this into 1 by beta into dx is equal to du. So what do you get here in this? So this is again alpha by beta into x by beta to the power of alpha minus 1 into dx is equal to du. And here x tends to 0. If x tends to 0, if x is equal to 0, when you put x is equal to 0 here, your u is automatically. So if x is equal to 0, then u is equal to 0. If x tends to 0, u tends to 0. If x is equal to infinity, u also becomes infinity. And also, see, x is equal to, see what is your x from this? From this, x value is equal to, it is beta into u to the power of 1 by beta. X value is, see, x value is u to the power of 1 by beta, 1 by alpha. It is u to the power of 1 by alpha, u to the power of 1 by alpha into b. Therefore, x to the power of r is equal to b, beta into 1 by r. This raised whole thing is raised to the power r. So you get this to be b to the power of r into u to the power of r by alpha. Therefore, say I will call this as 1. Therefore, 1 becomes e of x to the power of r is equal to, now substitute here, you will get 0 to infinity, because the limit for also the change of variable u is 0 to infinity, into x to the power of r is beta to the power of r, u to the power of r by alpha, into, you see that this alpha by beta into x by beta whole to the power of alpha minus 1 into dx. See, x by beta to the power of alpha minus 1 into dx is nothing but your du, and in this place I will write it as e to the power of minus u into du. I hope that you are able to understand what I write here. So you see that this is, this is x to the power of 1, I have got the value. X alpha by beta, see alpha by beta, x by beta to the power of alpha and 2 dx will be equal. So this and this combined together, you will get it as du. And this is e to the power of minus u. Now this can be rewritten as, I will write this as b to the power of r has nothing to do with the integration. It is a constant of integration. So you write this and it is 0 to infinity. I will write this u to the power of r plus alpha plus 1 minus 1 into e to the power of minus u into u. So if you call this as your k, let us call this as our k, or you call it as n, no problem, you can use this n. You call this as your n, this is u to the power of n minus 1 into e to the power of u minus u, e to the power of n minus 1, e to the power of u. So this is nothing but, this is a your gamma function, gamma integral. So you see that this is a gamma function. Because this is a gamma function, I can write this as b to the power of r into gamma of r plus alpha plus 1. R plus alpha. This is gamma function. Gamma r by alpha plus 1. Now e to the power of, now you give me the value of this. So e to the power of x by 1, which is equal to mu, that is beta of gamma of 1 by alpha plus 1. And what is your e of x squared? Second moment, e of x squared, second moment is equal to, what is that you get for this? So this is equal to b to the power b squared into gamma of 2 by alpha plus 1. So this is your base. Therefore, sigma of x squared is equal to e of x squared minus e of x whole squared. This is equal to, what is your e of x squared? It is b squared 2 by alpha plus 1 gamma of this minus, what is your e of x? E of x value has been formed. E of x value is equal to, e of x is equal to beta gamma of 1 by alpha plus 1 whole square. So this is equal to beta square into, within brackets, 2 by alpha plus 1 gamma of this minus 1 by alpha plus 1 gamma of this whole square. This is the, so I am able to find what is my, so first of all I find the rth moment. After finding the rth moment, put r is equal to 1, you get the first, the mean. Then put r is equal to 2, you get the second moment. Having found the second moment, you can find the variance, which is nothing but the second moment minus the mean whole square. That is e of x squared minus this. So simplifying this, we get this. So what is the answer that we get for this? So therefore, see I write here, therefore e of x mean of x is equal to, it is, see, beta into 1 by alpha gamma. This sigma of x square, that is the variance of x, is equal to beta square into 2 by alpha plus 1 gamma of this minus 1 by alpha plus 1 gamma of this whole square. So these are the, so I am able to get the mean and the variance of the two. Now let me explain how the problems are done in this. I told you that this is mainly applied for finding the reliability and longevity, durability of the components. So this is how we find. So I have explained to you, I have told you what is a Weibull distribution. It is a continuous distribution. What is the probability density function of it, and what are the parameters that are alpha and beta are the parameters. What are the importance of the parameters? We can discuss in length about drawing the graph and showing that how it is going to affect alpha and beta, how they are going to affect the components, life of the components. We can talk about all those things when we go deep into that. But coming to the problem as such, these are the things that you must know. And I have explained to you what is the mean, how the mean and the variance are found. In general, I told you how to find the rth moment. Having found the rth moment, you can get hold of all the moments. That is mean and the variance. I told you how it should be got. Now let us come to the problem. So let us come to the problem. The lifetime x in hundreds of hours of a certain type of picture tube that comes in a TV has a Weibull distribution. As I told you, this Weibull distribution is mostly applied to components of machineries to find out the durability, reliability and the length of the components. Weibull distribution with the parameters alpha and beta. See here that here it is alpha, I will write it as here instead of this, and I take it as your alpha and beta. Here you are given this alpha is equal to yes. Alpha is equal to 2 and beta is equal to. Compute the following. Now you are asked to find and you are asked to answer certain questions. 4 questions are here. So what is given here? They have given that the lifetime. So here x is a random variable. So you see that it is a random variable because the lengths or the life of the components, picture tubes, they vary. They are random variables. Okay, and they are in hundreds of hours. So the lifetime x of a certain type of picture tube has a Weibull distribution. So as the name is Weibull distribution, we have to write a Weibull distribution that I will write. With the parameters alpha and beta given like this, we have to calculate. Now, I'll write here, we know that fx of x is equal to, it is alpha by beta into x by beta to the power of alpha minus 1 into e to the power of minus x by beta alpha x greater than 0 and alpha and beta of greater than 0. So this is the PDF. See, we know that fx of x, this is your PDF of x. See here x is a random variable that is nothing but the life of the picture tube in hundreds of hours. Okay. Now you are asked to find the value of this. Now what is your x? E of x. Find E of x and sigma of x square. Now what is your sigma E of x? I have given here. See, what is your E of x? We know that E of x is equal to It is nothing but your beta into gamma of 1 by alpha plus 1. That is equal to what is your this thing? You have given alpha and beta. Alpha is equal to 2 and beta is equal to 3. So this is 3 into gamma of 1 by 2 plus 1. That is 3 by 2 of gamma. That is 3 into half into gamma of half. Gamma of half is equal to root of pi. This we can prove it, but at present it is not required. So understand that the value of gamma of this is gamma of half. Gamma half. Gamma half is equal to square root of pi. So you see that this is nothing but your 3 by 2 into it is square root of pi. That is 3 by 2 into square root of, it is 3.6, even you can put 22 by 7 square root of this. If you simplify this, if you go simplifying this is that is 3 by 2 into this, what that you will get here is, see the answer that you will get here is, I give you the answer, just it is merely working out. Now we just work out use the calculator and work out. So what that you will get here is 2.6588. So E of x, apply the formula because I have derived the formula for E of x. You apply you substitute the values, you will get 2.6588. So what is this? So E of x is equal to 2.6588. So this is our first problem, and let us come to the next one. See what is the next one? The next one is sigma of x squared. Let me work out this. So we know that sigma of x squared is equal to your beta squared into it is 2 by alpha plus 1 gamma of this minus 1 by alpha plus 1 gamma of this whole square. So this is equal to beta square. Beta square is, see beta is 3, so it is 9 into 2 by alpha is 2 by 2 plus 1 gamma of this minus it is alpha is 1 by 2 plus 1 gamma of this whole square. So this is equal to 9. This is 1 plus 1 is 2 gamma of 2. This is 3 by 2 gamma of this whole square. So this will be equal to, see gamma of 2 is, see gamma of n is equal to n minus 1 factorial. So 2 minus 1 factorial is, this is 9 into gamma factorial 1 minus half into root pi whole square. Because 3 by 2 is half into half, see again in ms, half into half pi whole square. So this will be equal to half. 3 by 2 is 1 plus 3 by 2, that is half into root of this one. So what is that you will get here now? So this sigma of x squared is equal to something. Here I have not applied because I have already derived this. I am substituting the values, and here I am taking this gamma of 2 is nothing but n into n minus 1 factorial. Here 3 by 2 whole square. This is nothing but half plus 1. Therefore this is 3 by 2, that is half into square, because half gamma of half is nothing but your square root of pi, because I told you that half gamma of half is your square root of pi. So I am substituting here. So you simplify, you get this. So your sigma of x squared will be equal to sigma of x squared will be equal to variance 1.9318 variance of x. So this I have done. This two I have done. Now, so this is I have not done anything. Simply I have already derived this sigma of x square. I have substituted the values. Simply substitute the values in the place of alpha and beta and go for a simplification, knowing what is the value of how to find the value of gamma of a very function. There's gamma function, gamma of a certain number like this. Gamma of 1 is, gamma of 2 is 1, n minus 1 factorial. So you get the value here. Substitute them, you simplify them, you will get the answer. Okay. Now let me go to the third one. What is the third one? Third question. Here it is x greater than 0. Here alpha, beta, greater than 0. Now you see that what is the next one? See here C. C is your B question. Your B question is P of x less than or equal to 6. So if you put B of P is less than or equal to 6 means this is nothing but it is 0 to 6 into alpha by beta into x by beta to the power of alpha minus 1 into e to the power of x minus beta to the power of alpha into dx. See, as I have done, do not bother even the limits, you need not bother. You can fix up the limits afterwards also. If you are going to do this, let me take this to be as I have done here, let x by beta to the power of alpha is equal to, you take it to be your u. If you take it to be u, then if x is equal to 0, u is equal to, it is 0. If x is equal to 6, see, if x is equal to 6, u is equal to 6 by your alpha beta value is, your alpha is 2, beta is 3. So you see that you substitute here, your 6 means beta is 3 to the power of 2, that is equal to 4. So you see that here u is equal to 4. So what is that you will get here? I have explained to you already how to integrate this. So you see that you will get this to be 0 to 4. This is nothing but e to the power of minus u into du. So this is nothing but e to the power of minus 4 divided by, it is minus e to the power of minus, it is minus u and divided by minus 1 and 0 to 4. So if you substitute the values, you will get this to be 1 minus e to the power of minus 4. This is u. This is 4. So 1 minus e to the power of minus 4 is simply, if you simplify this 1 minus e to the power of minus 4, if you simplify this, you will get the answer to be, so you will get the answer to be, I'll give you the answer. You simplify this, you will get the answer 0.9817. So what is the answer for this? So for this 0.9817. So here I have not done anything. See, if you want, you must know that if you want, you can differentiate. If you differentiate this, this will give you alpha by beta into x by beta to the power of alpha minus 1 into dx is equal to du. So you see that alpha by beta, see, it is like this. You are getting this alpha by beta. Here, see, alpha by beta, and this, this whole thing will become your, this whole thing is equal to your d. This one. So it is e to the power of minus, it is e to the power, see, I am taking this to be alpha, so the e to the power of minus u. So therefore I get e to the power of minus u. This is a simple integration. When you do that and apply the new limits, I have given you how the new limits have to be formed. If x is equal to 0, u is equal to 0. If x is equal to 6, u is equal to, you substitute the values, you get it to be 4. So So this is how we find the new limits. Now ordinary integration, you will get the answer. So this is my question number B. Now let us come to question number C. What is the question number C? What is question number C here? See, what is your question number C? Question number C is P of 1.8 less than or equal to x less than or equal to this. So this will be equal to, you can do it in many ways. You can find the cumulative distribution function and then do the problem, or you can straight away do. So this is nothing but what? 1.8 to the power of 6 into alpha by beta into x by beta to the power of alpha minus 1 e to the power of x minus beta whole to the power of alpha into dx. Now you proceed by the same way I have explained to you, proceeding in the same lines. I write here. See, take x by beta to the power of alpha as your u. Now, when x is equal to 1.8, if x is equal to 1.8, u is equal to, say what is your u now? It is 1.8 divided by 3 whole square. So this is equal to 0.6 whole square, that is equal to 0.36. And when x is equal to 6, x is equal to 6, u is equal to 6 by 3 whole square, that is equal to 4. So you have to put that. So proceed in the same lines. I write here, you have to practice this. Proceeding in the same lines as explained, we get P of 1.8 less than or equal to x less than or equal to 6 is equal to, what is the new limit here? 0.36 to 4 e to the power of minus u into d. So this is what you will get when you go do the simplification. So when you go for the change of variable. So this will be equal to, I write here. So this will be equal to, so what will be this equal to? So this is equal to, see, e to the power of minus u divided by minus 1, and this is 0.36 to, it is 4. Now when you apply the limit, it will become as e to the power, it is minus u. It is u, so it is e to the power of minus 0.36 minus e to the power of minus 4. And if you do the simplification, if you apply the limits, what that you will get here is, if you apply the limits, you will get the values. I will give you the answer. You just find the value of e to the power of minus 0.36 and find the value of e to the power of minus 4 and do the subtraction. What that you will get here is, your value will be, see, I will give you the answer. It is 0.6793. 0.6793. If you that is, find the value of this. Go use a calculator. You will find what is the value of e to the power of minus 0.36. Likewise, find the value of e to the power of minus 4. Do the subtraction. You will get this. So what is the answer that you are getting for this? So this is equal to 0.6793. So the answer for this question is 6. So what we have to do is, I have explained to you how to do the integration. Solving the integration is important. I have explained to you how to solve the integration, but you go for change of variables. When you go for change of variables, simultaneously you must change the limits also. I have explained to you how the limits are changed. Apply the new limits and use a calculator to find the value of e to the power of minus some value. You will get it. Substitute them in their places and do the ordinary subtraction or addition. You will get the answer. Nothing, it's not difficult. Okay. Now, let us come to the last one. The last one is, what is the last one here? What is the last problem in this? So, in this problem, last one, you see that P of this is your dx is greater than or equal to 3. So x is greater than or equal to 3 means you can write this as, this is nothing but it is from 3 to infinity. Because here it is x greater than 0, so it goes from 3 to infinity. It is again alpha by beta into x by beta to the power of alpha minus 1 into e to the power of x by beta into alpha into dx. So here again I told you that here you use the same take x by beta to the power of alpha as your u. Then when you put x is equal to 3. When you put x is equal to 3, u will be equal to what? 3 by what is the value of beta? 3 divided by whole square, that is 1 square is equal to 1. So x is equal to infinity. When you put x is equal to 3, u is equal to 1. When you put x is equal to infinity, u is equal to infinity. And you take now substitute, what is that you get? Therefore, alpha by beta into x by beta to the power of alpha minus 1 into dx is equal to du. Now substitute these values in these. Put the change of variables, so you will get this to be, it is 1 to infinity. And here as I told you, see this one, see this one, it will become du. So e to the power of minus u into du, that is equal to e to the power of minus u divided by minus 1, and it is 1 to infinity, that is nothing but e to the power of minus infinity. It is minus infinity plus e to the power of 1. E to the power of minus infinity is 0, so 0 plus e to the power of 1, that is e to the power of 1. E to the power of minus 1 is e to the power of minus 1. E to the power of minus 1, e to the power of minus infinity plus e to the power of minus 1. But e to the power of minus 1 value is, as we know always, as we know the value is well known one, or you go to the calculator or anywhere, you will find the value of this e to the power of minus 1. The e to the power of minus 1 is 0.3678. So it is equal to 0.3678. So this is all about the problem, and I completed all the problems. And what I have done is, I have introduced what is called the Weibull distribution. It is a continuous distribution. I have taught you how to find the ortho moment of the Weibull distribution. Having found, I am able to answer the questions e of x and the variance of x. By the way, you must know that this cumulative distribution function is equal to f(x) of x is equal to, it is 0 to x into alpha by beta into x by beta whole to the power of alpha minus 1 into e to the power of x by beta to the power of alpha into dx. So 0 to x. When you simplify this as we have done here, taking the value to be u and everything, you will get this to be again, here if you take, you can take this to be some x you take, and you can take this to be your alpha, you can take this to be your u. You can take this to be your u, because it's a random variable only, it is an arbitrary function. So you can take this to be your u. When you take this to be u, and if you can just go for the same method of this, you will get 1 minus e to the power of minus x by beta into alpha. So this is the cumulative distribution function. With the help of this also, you can answer all these questions. But I have taught you how to find using the straightforward method. Here also this you can use this method and get the answer. Even if you use this, you see that you will get the very same answers. So I am able to solve the 4 problems here, and I will discuss more distributions in the coming days.